So in today's video, I'm going to be working on a Muncie 4-speed, an M20 Muncie, by the way, with a 252 first gear. It's for a 1969 Corvette. It's a numbers matching transmission, so we want to keep everything as much as possible correct for this transmission in place. It's even got the little tag on it. This transmission was rebuilt already before. Customer complained that it was hard shifting, it was noisy. He really wasn't happy with the work that was going on with the transmission. So I'm going to just take the transmission apart and see what I can find, make some corrections, and get this unit back together again. So let's get into it and see what I can find. Get silicone sealer all over the front of the transmission here because probably it's leaking out of the countershaft, and the rebuilder who did the work probably didn't want to bush the case and repair this. So a simple job like this, where I'm supposed to maybe go fix the gears and check out the shifting action of the transmission, turns into a nightmare now because I have all this crap all over the unit that I have to deal with. So if we look at these assemblies, we can see how sloppy they are. Okay, that's number one. Sometimes this doesn't matter that much as you think it would, but sometimes it can cause hard shifting issues. And the other is the rings, they look good, but I don't think they're going to be grabbing the gears properly. So take a look at that front bearing retainer, not how chewed up it is. That's because the person didn't have the proper wrench and used a pair of channel locks or pipe pliers. There's not a problem with doing that actually, but it would be a good idea to clean this up before putting the bearing retainer on there. Because when you do this with pliers like this and you chew up the edge, you're actually chewing up the sealing ring of the gland nut. And what happens is inside here then, you start seeing where it might have been rubbing against the inside of the bearing retainer. And that's not cool. It's a nice retainer. Somebody's poor workmanship caused that. One of the first things I noticed on the extension housing that stood out to me is the plastic 8-tooth speedometer gear, which was typical of 1969 and 70 transmissions. It's held in with this little clip over here. So the problem is that because these is held on with this little tin clip over here, if the cable at all binds up, the gear just gets spit right off the clip. It's not really held on that tight, and the clip will just kind of come out, and then you'll have to take the whole transmission apart. So always replace these with the steel gears that are pressed on. I don't like these gears. The other is I'm looking at, I don't know, I haven't seen Indian head shellac in a long time used on gaskets, but one of the problems I noticed with this transmission was that when I put the yoke in, it was fighting me. And this person very aggressively used some sort of cutter to clean up the gasket surface. You should never do that because these gasket surfaces are held within 2.5 to 4 thousandths, okay? And by just using a cutter like this, you totally ruin how the two surfaces end up being parallel. That's really not the thing to do. Take your time, scrape the gaskets off, maybe use some steel wool or something like that. But never use some sort of rotary abrasive on this. And you can see how the whole surface here has been just changed drastically. Factory reverse gears always use these anti-rattle springs. It's basically to keep the gear tight on the spline. The problem with these springs is that they get loose. See it over here? They come off really easy. There you are. I always discard these because usually they end up breaking and jamming the gear. Typically the gear goes in reverse, the spring pops out behind it, and then you're stuck in reverse. You don't really need these springs. It's never really caused an issue. I never put them back in. So the first thing is the synchronizer rings. I tested them out and they're not grabbing the gear. You can take your 3 fingers and put them in the key slots like this, apply pressure and turn the gear. A good ring should stop the gear. I'm putting a lot of pressure this way and the gear isn't stopping. And that can happen because of 2 things. Usually just a bad ring, in other words the ring is just a poor quality ring, or the threads inside the ring, which they do appear to look like they're glazed, where they kind of mash down because the clutch isn't releasing, for example, or the pilot bushing is hanging up and there's still a lot of pressure. The ring is actually overworking and doing more than it has to do, and it flattens out the threads and then the ring doesn't grab the gear. Now, if I take, for example, a better quality ring and put it on here, the synchro height is still about the same, but I turn it and it immediately locks up. There's no, as soon as I hit that thing with some pressure, the ring is stuck to that gear. It doesn't want to move. And that's what you want to go for when you're trying to go test out synchronizer rings. So it's possible you can get a new ring and put it on a gear like this and turn it, and it really doesn't grab it. That's going to be a hard shifting issue. So let me just show you what I'm going to do here. So these are the 3 second gears that are currently available in the market. This is the Taiwanese second gear. It's a nice looking gear. It's available on eBay. A lot of people are selling these gears because they're dirt cheap. Second in line is the Italian gears. These are sold through Auto Gear Company up in Syracuse, New York. They've designed the gear to their prints, and it's a very nice looking piece. And here's an OEM gear. This is an original equipment OEM gear. None of the gears are the same, and that's a problem with rebuilders in general. There's nothing you're going to do about it. You're going to just have to work around it because that's the way it is. So what we're going to do now is put this ring on this gear. I want you to do is take notice as far as how much the gap of the ring is against this gear over here, okay? And that's the space in between it. It's still acceptable, but it's on the low side. When I put the hub against it, you can see how much clearance the ring has against the hub. You need clearance so that the gear is actually thrusting against the hub and not the ring. Take the same ring, going to put the OEM gear in place. You see pretty much we get the same clearance, okay? It's a little bit tighter. If you look at it, the ring is sitting a little bit higher on the OEM gear compared to the Taiwanese gear. This is definitely sitting lower on this gear cone and has more space than the original equipment gear. And if you have too much space, the keys that are in these slots are going to pop out. Now, if we look at the Italian gear, we have the opposite condition. The ring is a little bit too high and has very little space. And that can bind up the transmission. This is what you're working with today. Put the forge ring on Italian gear. It's the same situation. It actually sits a little bit higher. Look, we've got basically no clearance at this point. And we have to worry about that because now this gear can actually thrust against the synchronizer ring rather than the hub. Nobody's checking quality anymore. We put the Taiwanese ring on it, we've got gap, okay? We put the OEM gear, original equipment, GM gear, we have gap. So, 3 gears, 3 different tolerances. Also, let's look at the back side of the gears while we're at it. Notice that the Taiwanese gear, they did a little bit of a clean out there to reduce some weight. OEM gear has it, a little bit bigger. Italian gear doesn't even have it at all. Thrust surfaces on the actual Taiwanese gears and GM gears about the same. And even though they really only grab on this area, the Italian gear is shorter. And one thing I got to do on all these boxes is that the OEM gears and the Taiwanese gears and the Italian gears, for some reason they refuse to put oil slots in the thrust surfaces to help them lubricate better. So when I build a box, I actually have to grind a little notch on the surface so they can lubricate better and not seize up onto the main shaft. The engagement teeth of the gears, I'm going to see if we can focus in here. These are straight cut engagement teeth. They're non-torque locking teeth. So they work very well with torque locking sliders and non-torque locking sliders. I'll get to that in a second. On the Taiwanese gear, the teeth are back cut. These can only be used with torque locking sliders because these teeth are actually running at an angle like this. So it's very important that you use the proper slider with the gear. These are torque locking sliders. You can see inside the spline here, they have a back cut to them. The problem with these torque locking sliders is that they pull the gear in too far, and that's a problem. The other problem with this guy's transmission was they used soft hubs. Now GM has used soft hubs in the past, but when you use soft hubs, I don't know if you could see the spline. Now this was new and not used that long. You can see already the spline of the hub is getting beat up from the torque locking slider cocking on it. And it's a problem because nobody does matched assemblies anymore. If I take this slider and hub and put it on here, we have a fair amount of slop on there. And that slop is going to correlate to the slider digging into the soft hub and hanging up on it and causing it to shift hard or hang up in a shift. Let's look at that again. I'm going to put it together so you can see. Now this clearance isn't too bad. Okay, we're going to put it right up at the edge because that's where it is. It's not too bad, okay? There's some play in there, but it's acceptable, but not acceptable when you're running a soft hub. And let me give you an example. Here's some of my zero rock assemblies. These are hardened hubs. Put them on here. Okay, there's no movement. I'm going to hold this as steady as I can here. There's very little movement compared to the other ones. So after I removed that sealant from that main case, I tested the fit of the countershaft, and it actually fit pretty good. But what I do is when I use new countershafts, I use extended fit countershafts in Muncie cases because they take advantage of areas in the cases that were never used before. So let me explain how I prep the front hull of the main case. I use anaerobic gasket maker on the front bore of the case, so when the countershaft presses through, the absence of air creates a nice seal. Even though it's a decent press fit, I'm still going to do that, and I might even coat it with a little bit of epoxy after it's done. On all my regular stock rebuilds now that require a mid plate, I use these new billet mid plates I have made. There's two good features about it. Number one, they're made out of solid aluminum. They are much stronger than cast aluminum plates or die cast aluminum plates. They have a little bit extra material in the front for the snap ring groove. And there's a pretty good cross section over here in terms of the thickness of the ring groove relating to the webbing over here compared to some other plates that are out there. What I've also done is incorporate the anchor hole for the countershafts that have the anchor bolt, such as this one over here. These countershafts have anchor bolt holes in them. Now there's several different countershafts out there on the market with anchor holes in them. This is my extended fit countershaft. It actually increases the surface area over here that bites into the case. It's a little bit longer shaft with a reduced chamfer in the front to again take advantage of as much surface area as possible in both the front bore and the rear bore of the main case. So what I did here is I drew some yellow paint on the raised portion of the countershaft that fits into the back bore of the main case. And this is our extended fit countershaft, and you can see visually how long that area is compared to the GM version and compared to the aftermarket version commonly seen on the internet and the Auto Gear version. Auto Gear actually has, surprisingly, the smallest area of bite than any of the shafts. On the front end of the countershafts, to maximize load-bearing surface in the front bore of the case, the extended shaft has about a 15 thousandths overall length that's longer, still works out to the front end of the case, and less of a chamfer. So you gain about 30 to 40 thousandths worth of bite more with this shaft. This is the factory shaft, which has a rounded chamfer, and you lose about almost 60 thousandths. The aftermarket shaft is actually pretty good. It's almost the same length as the extended shaft, but a little bit shy with less of a chamfer. The Auto Gear countershaft is about 15 thousandths shy than the factory shaft, with at least a 60,000 chamfer, making this countershaft actually the shortest of the bunch. So if you're working on an older case and you want to maximize the surface area that the countershaft is engaging, the extended countershaft is actually perfect for that. One of my little designs. So the other problem was gear noise. This person had installed an original, could be the original counter gear, with a brand new first, second, third, and input shaft. Now again, these gears aren't that bad. These are Taiwanese gears, and people, by the way, I'm going to tell you this right now, any of these Taiwanese gears has an AT on the back side of the gear, and a date code that the gear was made. AT stands for All Transmission in Portland, Oregon. This particular gear is made in Taiwan again. Don't be fooled by people selling these on eBay and telling you they're made in the United States. They are not. I know this company very well. I know the people who make it for the company, in fact. And these are made in Taiwan. They're not bad quality, but don't be fooled by people telling you, again, it's made in the States. The problem with these gears, again, is that the synchros fit a little bit low on the gear. I don't like that. And they don't grab the comb because the ring is bad, not the gear, okay? Using, again, a good ring on the gear, it works fine. So you have a problem with using crappy rings or crappy gears. But here we got now is new gears running against an old counter gear. And sometimes that can create a problem because this gear has been wearing a certain way for 45 to 50 years. Don't expect that if you're going to be putting a new gear against it, that it's going to be quiet. So this person was complaining about third speed gear noise. This is the third speed gear, this is the counter gear. I put them on here, they feel really good, actually very smooth. So why would they make noise? In closer inspection of this gear, and I start spinning it around and looking at it, looking at the teeth of the gear, what you start seeing is pit marks. And these pit marks and these little indentations indicate that the gear teeth themselves are starting to maybe distort. Maybe they're starting to move around a bit. And it's not that bad, okay? This is not a bad gear. And it probably would work well with the original third gear it came with. But there's definitely some indentations in the teeth over here, that the teeth are starting to move and wear out, and possibly with that new gear against it, it could make noise. It wouldn't have blown up or anything, it would have been fine, but the customer again is not happy because it's making gear noise. So as a builder, you have to consider these factors, because do you want to help the customer out and save them on a counter gear, but then risk it being noisy? Not worth doing. There's a small issue with small parts. It's not a big issue, but it can be a problem. Most of the rebuild kits out there, or small parts kits, have steel-coated thrust washers. They're steel washers that have some sort of coating on them, and you could see the coating is already wearing off. And when that happens, it's just going to fail. This had less than probably 50 miles on it, and already the steel is starting to dig in. Having steel against a steel counter gear isn't really a good idea. The old washers were Babbitt. The new washers, now you can get these dimpled bronze washers. This is what I use. When I put my transmissions together, I actually do not buy small parts kits. I actually buy all the individual small parts myself and put all the components together. So I use these bronze dimpled washers. They have nice little areas for oil to kind of hang out in them. They work very well. I've serviced racing units that I've used these washers, and they've never fallen apart. Next up is the shift forks. And what I wanted to do is show you that the forks show some signs of wear on the edges of the forks. It's not bad wear, but it's very significant. And a lot of people don't understand why this happens. Sometimes it's from normal wear and tear. And if I put this fork in the groove of the slider, usually most forks and sliders have about 12 thousandths to 15 thousandths play in them. And you can see here, the play that we have. And this will cause the transmission to pop out of gear and not engage fully, and the slider to move around where it shouldn't be. If I put a new fork in the slider, you can see that's reduced to almost about, like I said, about 12 thousandths. So that's what you want. A lot of times what people don't understand is that the wear of the fork is caused by these torque locking sliders. Because if you think about it, I'm going to do a video on this, but the fork is held stationary by the side cover, and the slider starts pulling itself into gear and going this way against the fork. So the fork is the only thing that actually keeps the slider from going forward or backwards. So when you put a load on it from torque locking, the slider loads up against the fork. It's like, say, in this direction or that direction, and it wears the fork out prematurely. So I don't really use torque locking sliders unless it's extremely necessary, where I can't get the gear replaced. Second design factory Muncie M20 counter gears have this anti-backlash plate on them. It's got 3 rivets, 1, 2, 3. And if you notice that these rivets have scrape marks in them, that's because they've been getting loose and running into the front of the case. When I build these transmissions, I always take this plate off. When you see this, obviously the rivets are starting to walk forward, and you need to remove the plate completely. If you don't, eventually you'll have a failure. The plate will come off, get stuck in between the gear, and cause a mess. So because that old plate was messed up from somebody putting a sanding disc on it, I'm installing one of my new billet aluminum plates on this one, and I'm pre-fitting everything to make sure that it fits correctly and that there's no high spots. Everything looks great. When using these new aluminum plates, you have to open up these holes to 5/16 because I use a standard 5/16 dowel in this. So we're going to replace this midsection again with billet aluminum. So I just want you to show you the new setup with the new M20 gears. And I don't know if you could see, but you can see that the alignment on the third gear to the cluster is much better than it was before. Second gear always overhangs this way a little bit. It never actually goes to the edge on any Muncie. But here we have a pretty good third gear alignment with the cluster. Got 2 new Zero Rock synchronizer assemblies, all together with new Ford synchronizer rings, hardened hubs. It's all ready to go. So thanks for watching this video. Please leave some comments below. Let me know what you think of it. I just wanted to close with one thing. As you can see hopefully in the video, that even when you get new parts, it doesn't mean that the new parts are great or that they work correctly. And this is a problem that I'm faced with on a daily basis. Because even the parts that I use in my builds, they require some sort of setup. The days of being able to kind of just get something out of the box, put it in the transmission, and send it out the door, they're gone. That doesn't exist anymore. It requires some attention to detail, and it requires knowing how things are supposed to work. And that may be the key to this whole thing. Because if you really don't know how things work with one another, and hopefully by me showing you these videos you do, you'll get a better understanding of how a part should be as far as the level of quality and what you should expect out of something. Well, I'm seeing a lot of people that are on eBay saying parts are made in the United States when they're not. And that isn't even really an issue at this point. The issue is whether or not they actually work. Because putting this part together in a gearbox, putting the whole thing in the car, only for it to have to come out again because it doesn't shift, that's just wrong, you know, but it happens. So please check everything out. If you want any questions answered about something you're looking at buying, I don't care. You can hit me up on Instagram. You can hit me up on Facebook. My email address is support@5speeds.com, and I'll answer your questions. Or leave some comments below. Thanks.